So I'm going to go into simulation theory, the Mandela Effect, how they could be related, and hopefully blow your mind. So I'm going to lead up to what is the foundation for simulation theory. So if you get two rocks and you mash them together, okay, they create a junction. And these junctions were studied by physicists, and finally they found out that if you purify silicon and you put two different types of silicon together, the N-type and P-type interesting properties come about with electricity, which was understood. Two crystals that join together in such a manner are called a diode. So after further investigation, this diode is the transistor. Okay, so a signal comes in to the transistor and then comes out differently, changed, right? Amplified, right? So it turns out that when you put two transistors together like this, it forms a logic gate. So the logic gates were talked about in philosophy for decades, hundreds of years, if not thousands of years. And logic is a way of thinking. So with these logic gates, right, you can construct an adding machine. This is called, right, the half adder. If you construct this with the logic gates, it's called a flip-flop or a register. Okay? So the registers and the adder form a CPU of a computer. A few transistors make up the CPU, the computer. The memory is just these flip-flops in an XY two-dimensional pattern. Okay, that's the computer, memory, and logic. How is that relating to simulation theory so far? So each of these gates only have two states, 0 or 1. So with ones and zeros going through the CPU and the memory forms the basis of all of our electronics, okay? So what was done is computer languages were formed to interface human languages with the computer languages. C language, C++ language is what Unix operating system is made from. And the Unix system is a project, uncompiled project in C language running on these computers. The Android language, the Android system is based on Unix, which is a C++ project, okay? Windows is an amalgam or a simulation of Unix. Windows wants to be Unix. It's taken as a model. So we're up to Windows 10, right? Unix has, I don't know, a lot more updates to Unix because it was around longer. So your brain, the neurons, so that's a neuron, okay? Dendrites and axons. The nucleus of the neuron. Every neuron in your brain works on zeros and ones. The dendrites collect the signals. They're added up in what's called the axon hillock, right, by the nucleus. And then if there's a 1, it fires the signal on the axon. Okay, down the axon. If there's a 0, the axon is inhibited. That is why the neurons act like a computer. So how complicated is your brain? All of your thoughts. Zeros and ones, okay? All of those neurons. If not already, there's going to be a computer made that has as many neurons as your brain. Okay, so what's the minimum amount of neurons for consciousness? What about for a bumblebee? Why is it that sentience has to be based upon human consciousness? Maybe it's just the language center, right? So no one is building a brain out of logic gates to match the neurons of a brain. Because in software, you could create neural networks. So in other words, you could just make a simple computer and a lot of memory and run a program stored in the computer. to act like the human brain. I wrote a book on neural networking where I gave you the code to create a human brain. Okay, so I've taken you from jamming two rocks together to make a transistor all the way up to the human brain. So why do physicists think that the universe could be a simulation? Alright, so the universe is a sphere of everything you could see in the telescopes, and maybe a little bit outside that you can't see. That's what it's currently described as. And they think that there was a big explosion, the center, and the universe, right, expanded. Some say that, right? There's been some stars that are even close by, that are about the same age as they think the whole universe started out as. So they're thinking, well, okay, so that's the best thing that we've got right now. Then you have this observation of our solar system. The orbit of Mercury and all the planets can be mathematically modeled in their orbits, except for one detail. Mercury rosettes so people are saying, what the fuck is that meaning, right? So Einstein so it's as if gravity is like, and Mercury is going, down a funnel to be swallowed up by the sun. That's the theory of relativity. So there was a theory of gravity from Newton. He dropped a cannonball from a tower and fired a cannonball straight horizontal, and they both hit the ground at the same time. So there was a formula for gravity. And then Einstein came up with four-dimensional space-time to explain the orbit of Mercury. So gravity got an update. So when that happened, the formula for energy and matter had to be reconciled. So all matter is energy in some kind of resting potential state. So everything is energy. So when you get into chemistry bonding, alright, so you can't see that. So people recognize the neutron, proton, and electron. Except it doesn't work that way. Electron bonding is orbitals. The orbital cloud. So in the nucleus is in the center. The electron is in a cloud around the nucleus. There's a probability where the electron will be found in the electron cloud. Okay, the electron can be never pinpointed around the nucleus. That is called the uncertainty principle. And the epsilon equation for these clouds are called the Schrödinger equation. The electron is quantum tunneling from one point to the other. In other words, one electron will be here, the same electron be here, and not pass the space in between. Those electrons are going to a parallel universe, and I am not joking. Okay? You've just had your mind blown with a taste for quantum mechanics. So, you see how this is getting into the Mandela Effect now, right? Every electron in the universe is going to, you assume, the nearest parallel universe, or the nearest couple parallel universes, however many there are, and coming back in quantum tunneling. See, you don't need to, I mean, it's mind-blowing as it is. Why aren't, why, what are the professors, they're pretty calm about it, the possibility of a Mandela Effect, because, so you learn at quantum mechanics in second semester, chemistry. So you're going to be a freshman or sophomore in college. So chemistry, you're going to memorize all the periodic table of elements. I've got something that'll blow your mind about that. Then you get into quantum theory. So then you have 2 semesters of organic chemistry, or 3. The carbon orbital that carbon life is based upon is going to be of great interest to you when you go into organic chemistry. You see how it's before you were this far from simulation theory, the Mandela Effect. So all of a sudden you're now saying, oh, the Mandela Effect. It could be based upon the uncertainty principle, quantum mechanics. Yes. Yes. It's very possible. Right. We've had, let's say there's a solar flare and it blows off, antimatter or matter or something, and 75% of our matter goes into the nearest parallel universe by quantum mechanics, and their matter, 75% of their matter goes into our universe. Right? So then people go, well, geez, that's a glitch in the matrix. Yeah, it is. Okay, so what percent of the matter in the universe can you measure and interact with? Not a lot. Dark matter, dark energy. It's as if we are existing on the screen of a system with the energy and matter we could interact with. And all the dark energy and dark matter that we can't measure is orchestrating the universe. So, we're like a projection, and we can't see the projector. We're a 4-dimensional projection, and the dark matter and the dark energy are creating the projection. So you see how basic computer and memory is. Junctions of silicon form transistors and logic gates. So with what we know of dark matter, dark energy, and the universe and particles, it could be where the universe at a certain level is a computer. Say at some level in particle physics, the junctions have formed memory, right? And so then at the particle level, those memory cells are what the universe is running on as a program, right? And so right now in philosophy, we think a lot about programs and computers. It's only natural for us to take that to the next step and view the universe as a program and a computer. Maybe you'll see that now, you know. But that's the simulation theory and the why, you know, our brain and universe work like a computer.